Okay, so today we will consider the group generated by the following polystrings. So we have 4 polystrings, so that's the second one. Y, X, I, Y. Third one, minus I, Z, Y, X. And the first one, which is minus Y, Y, Z, X. So you can create the matrix associated to this. So you see the number, the first column is just the number of I in each poly matrix. So here we have 2I because I square is equal to minus 1. And so here we have 1Y. So it makes 2 plus 1, it's 3Y, 3I. Here we have 2I. Here we have 3I. Here we have 2I here, 1I here, 3I. Okay. And so after, if you have a X, you put a 1 here. And a 1 at the right side. A Y. Or not, that's a 0, I think. Yes. And so for the Y it's a 1 on the 1. For the X it's a 1 left, 0 here. And I it's just 0 and 0 because it's the identity. And so trace are like this. He puts a Y here. So it's 1, 1. X it's 1, 0. I it's 0, 0. And Y is 1, 1. So I 0, 0. X 1, 0. I 0. Well, not sweet. It's a Z. A Z 0 here on the 1 at the right. It's the opposite of the X. That's why you have ZX calculus. It's like opposite things. Less or more. Not in terms of matrix, but not the same matrix, and say complementary matrix. So Y is 1 and 1. And X is 1 and 0. Finally, we have 1, 1, 1, 1. Because we have 2Y. 0, 1. 0. Applying what we have say for z and x. Okay. So that's the first step. Now the second step is to identify the number of pivots we need, and for that we just need to find first the rank of the matrix because the number of pivots is the dimension of the matrix, which is 4 here because we have 4 lines, and the rank is just uh, uh, the number maximum of independent vectors. So here we see that we can do, we'll find a way to do 0 0 with the columns. So you can clearly see that this line and this line disappear. So, and we can clearly see also that if we add this line on this line and this line, it will be 0 0 0 0. So we have two independent vector. So the rank is 2. So the dimension minus the rank is 2. So we have 2 pivots. So we can just trace out a line like this because we just find that we have two independent vector. And if we apply it, we obtain. Let's begin by maybe do the addition of this one, second column and first column into the first one. I'll do the explanation of how we change the phase of I at the left just after. Okay. So nothing changed for the other line. So here it becomes 0, 0, 0, 0. So we just do L4 takes L2. I begin like it's line 1, 2, 3, 4. I don't have line 0 because it's easier to think like this, maybe for some people. Okay, so you do here too, so it's 0, 1, 1, 1. Okay, and so the phase is just 2 and 3. It's 5, and you made 2 on the product of these bases. So it's like 1, 2, 0, 0. So it's 9, but we are modulo 4, so it's 1. While here in reality we have 1, 1, and 1, and 2, so it's 4. And because we are modulo 4, it's not 3 here, but 0. And so, because it's 0, it just the addition of 0 and 2, and so it's 2 plus 2 by 2, which is 4, so it's 6 modulo 4, which is 2. And so here we go. As I said you, we can you already see that I can do the addition here. So here if we addition the 3, so it's just like L3 takes the value of L1 plus L2 plus L3. Maybe I can explain you still, like, yeah, maybe I can explain you better here. Like the fact is we have 2 is because so we addition like this one and this one, so it's 0 plus 2, and after we made like we take as a diagonal like this one and this one, and we multiply it like, let's call this like p1, p2, and here we call it v1, v2. You can call it as you want, but the fact is you just need to do p1 plus p2 plus 2 times v1, v2. Just the product, so you know here it will be modulo 4. So here it will be 2 plus 0 plus 2, 1 plus 1 plus 0 plus 0. So it's just like 2 plus 4, so it's equal to 6 modulo 4. Which is why you still have 2. Someone is calling me. Oui, allô? Ouais, ça a fait. Ouais, ouais, c'est déjà fait, d'accord, bisous, bisous. Okay, so let's back to work. So, so here we have this. So here we addition 3 of them, so it's 0 here. So, well, so it's equal to 2. So here is line is just unuseful. Don't know why I've drawn it. Okay, so here we have 3, 2. Well, you redo it like this: 1, 1, 0, 0, 1, 1, 0. 2, 1, 1, 0, 1. 1, 0, 0, 1. So it makes 0 here, 0, 0, 1 on 1, 0, 1 on 1, 0. So that's cool. Yeah, the goal first is to have the first the left matrix at the bottom to be 0, 0, 0. So we achieve the first step of what we wanted to do. So we addition 3 of them. So 0, 1, 1, 1, 0 gives 1. 1, 0, 1 gives 0. 0, 0, 1 gives 1. 0 and 0 gives 1. And the same here. Okay. Here I have to. You reapply the tricks that it gives you here to get if is there. So it's just 3 plus 2 plus 3, so it's 8. And you do this one on this one, so it's like 8 plus 1 2 2, so 1 0 0 0, so plus 2, and here plus this, it's like 0 1 0 1, so plus 1, and you multiply by 2, it's 2, so it's 12. 12 when you for 0, because it's exactly 3, so you do not have some reds, so it's literally 0. So you achieve this. Okay, and you have the identity here too, which is pretty cool. Okay, second step. So we know you have two pivots because the dimension is 4, and we have two linear independent lines, so the rank is 2 and 4 minus 2 is 2, so we need to have those two rows to be 0 at the top. So how can we fix this? Solution first is to just put a 0 there and after a 0 0 now. So we just need to take this matrix and we have just to put this, well, because it will change, will 1 1 1 0. So we just have to do L1 takes the value of L1 plus, well, because it is a pedagogical video, I will do step by step, and I recommend you to do the same because you can do mistakes really fast, so just do step by step. Do not do like I just do L1 equal no, I can do L2 equal etc in the same palm, but I will not do it. L1 is just L1 plus L4, and this way we get to 0 where we want to get 0 here. And so here you just add 0, so it's the same, and here it just becomes 0 0 1 1. The other thing to change. 0 1 1 0 0 1 1 0 0 1 0 0 0 0 1 0 1 1. And so here it becomes 3 and 2 5, take this and this, you multiply by 2. 2 plus 3 is 5. And here we have 0, 1, 2. So 2. 2 multiplied by 2 is 4. And you add 5 is 9. And you add 4 is 1. Okay, so now let's do the next step. Just put L2 is equal to L2 is L3. So it becomes 1. So 1, 0, 0, 0, 1, 2, 1. Um, so you put your 0, my guy, like this. So it's 2, 0. Uh, yeah. Okay. I put this line, but it's not important. Just to say we have our two separate vectors, and that's why we have two pivots. So 0, 0, you add that, it makes you 0, it makes you 0, and it makes you 1, it makes you 0. Okay, and so here, same trick, so you add literally this and this, so it's 0 plus 2 plus 1, 0, 0, 2. 2 by 2 is 4, plus 2 is 6, modulo 4, it's 2. So here's our final matrix. Yes, that's it. So here we have our final matrix. Now we will need to put the Z stabilized states given by the polystrings out of the results of the simplification of this parity check matrix into an equivalent one. So how to put the Z state stabilized by the given polystrings? So just just here and it's a zero by the way. Maybe it's not really clear, but okay. Um, yeah, you need to have some rules for doing this, and the rules are the following. Let me find you the rules. I'm here, guys. Do not worry. I was just speaking with a friend. So now I'm checking for you my notes of some course. Oh no! Don't tell me my audio will just sleep along. Please, please, please don't sleep along my. Please, please, please. I'll be fast. Please do not go back my computer, please. But I have an idea. Okay. Well, you know what? I'll narrate through the rules better. You know. So the rule says that now we have this. We just want to have this rule in mind, which are, well, you know what? I just write through the rules going through. So here we'll apply the rule saying that now the goal is to have 0 here. And so we have a rule saying that if we have k with k being what you want, 1, really hard to draw on this shit. That if you have like k, so k being this, and you have a 1 here somewhere, so here you have something, and here too, and the 1. Well, now we have better. We have this. Is that we have, if you have something here, and 1, and 0, and here you have something here, so it says that the position is at the position E, and here you have the position G. Then you just have this, and it becomes 1, 0 equals 0. And you can change too, you know, so you can have like 0, 1 here, and 1 here, 1 star here, and you have 0, 1 and 0 star. So you can apply it both. So you can here apply, for example, so here you know you just have for identity, does nothing for the moment. And here just we can apply here a pi over a pi. We can apply, so we have 1 0 here on qubit 3 and 4, and equal 1. So equal star can be what you want. So here it's 1, and so it become 1 0 equal 0. So we have 1 0, and 1 1 will just become 1 0. It stays the same. So here, so you literally have 1 1 1 0, and here it just a CZ gate by definition. Because we apply it on qubit 3 and qubit 4, it means we'll have a second qubit 1 and 2, and the CZ gate on qubit 3 and 4. Okay. So now here it becomes, so we have 1 0 equal 1, so it becomes 1 0 0 0 1 0, the star remaining the same. Okay, 2 1 1 0 1. So here we have 0 0 1 0, and here we have 0 0 0 1 0 1 1. And so we have here 2 0 0 0 0 0 1 1. Okay. So here we are. Now we want to apply the same, but we reverse. So you see here we have 0 1. So just have 0 1, and here we have 1 0. So it just reverses it. And you know, when you apply on qubit 3 and 4, you should do it on all of them. So here directly, when you apply one column, you should do, so 3 4, you should do it here, 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 and here. Because here and here there is nothing, it will not apply. But because here it's 0 and 1, you just reverse, and it becomes 0 1. It becomes like 0 1 1 0, and so it becomes 0 1 0 star. So here it becomes 0 star. So here it's not a 1 but a 0. Okay. So that's literally this, okay? It's the first step of building synthetic stabilized one. Uh, um, um, okay, what's next? I have this. And we should go destroy this one. And so to destroy this one, there is a rule saying that you should have K11. The 3 point is just to say there is something, there is the other letters, the other number. And here you have 1, 2. And here is the position I, and here is the position G. Then we just get K-1 of 1, 1. Of 1, 0. Just like this one goes here, K-1 becomes a 0. So we get this. No, we get this. So 1 minus 1, K-1 becomes 0. And here we just have the same 1, 1, 1, 0, 1, 1, 0, 1, 0, 0, 0, 0, and 0, 0, 0, 0. And here we get 0, 0, 1, 0, 0, 0. Well, now here it becomes a 0, so 0, 0, 0, 0, and here 1, 0, 1, 1, 0, 1, 1, 1. Okay. That's it. And so you just had this rule, you just applying pi over 2. And so we apply it on the or skip it because the one is here, and even if you apply here, here, and here, it does nothing, so it's okay. And so you just take the same one as before, so we get this before, but because we have a pi over 2 on the last one, you just have here a pi over 2. And this is the representation of this. What's next, my babies? Um, so we are here, and that we need to apply now is the fact that there is a rule saying that if we have 2 here in the first row, 1, yeah, I don't put everything as before, do something here, something here, then it gives 0, 1. And we have a second rule saying that 2, so this rule will be, we have 2, 1 somewhere, becomes 0, and the second rule, so it will be for this one, the second rule it's here where we have a 2, and just a lot of 0 after, only zeros, and after we have like a 1 somewhere, and it says it's the same that having 0 somewhere on the 1. And so here that's just a pi, a black pi, and here it just just a black pi, and here I just a white pi. And so here we just get the same matrix, but we have 0, 0, 0 like this. So we apply this one here and this one here, and so it just gives 1, 1, 1, 0. So the same matrix, you know. As you can see, it just changed nothing, just the phase. Okay. So we get there. We just apply, as you can see. Um, so we just apply. Here it will be applied here because we only have one. So it would be a P white phase in the second one, a P black phase in the second one. Let me check. Yeah, so here it would be a P white phase in the first one, and the P this way it is not impacted. And a P phase, P black phase in the first one. No, P black phase, first one, white phase on the second one. No. Black phase. So let's begin by this one. This one and the second. Yeah, the second. No, okay. So for the white phase, white phase is the first one. You see, it's here. So just like just here. KK minus 1. No. Okay. Well, so one was in third position here, and it becomes a 0. So here the p over 2 is not here, but here. Okay, so here we are. We have so pi here, pi over 2 here, and on the second one, so here we have the black pi, and nothing on the first one. So at the end, here is our matrix, which is Hz, and our final stabilized state is just this black pi refuse pi over 2 refuse pi. Okay, so that's it. I don't know if I do use a third, um, like the, yeah, maybe let's finish at least this one. So now we just see we have two lines, so we put two black pi, and we have four white because we have four columns, and so the first black is connected to the first one, and the third one on the first one, and the second one is connected to the three last one. And so that's the final results you should obtain. Of course, you should plug this. Well, to be literally we have the pi here, the black pi, the pi over 2, and the pi. Maybe it will be, if we do it properly, it's better. Yeah, that's it. Well done.